So the question is related to the magnetic field around a wire which is carrying a current. So as I here, we don't need a direction, the pattern we need. So because near the wire, the magnetic field is stronger, so the line should be closer. And as we move away from the wire, the spacing between the lines should increase, which shows that the magnetic field is decreasing. So that's why B is the right answer. Which diagram represent the direction of a magnetic field around a straight wire which is carrying current out of the page? Like, which is carrying current out of the page means when you apply the right hand rule, your thumb should point towards you. Remember, A and C are totally incorrect because that does not represent a magnetic field pattern. It represents the electric field pattern. So either B can be there or D. What's the right answer? You can use a chat to answer this. So the right answer for this one, if you apply the rule, because the current is out means it should point towards you. So when we apply the rule, it will, using a right hand grip rule, so it will come out as option D. The figure 10.1 shows a cross section of a wire carrying a current into the plane, like it's carrying a current into the plane, inside. On a figure, sketch the magnetic field due to a current in the wire. Detail of your sketch should suggest the variation in strength. Like how your sketch can show a variation. First thing, because it's a straight wire, so whenever it's a straight wire, it will always produce circular magnetic field. Near the wire, the line should be closer, and as we move away from the wire, the spacing should increase. That shows a strength. And what about the direction? For a direction, we have to use a right hand grip rule. Because the current is into the plane, so your thumb will point into and your fingers will turn around it. So if you apply the rule, it will appear like this. As the current is into and the fingers turn around. So how you score the 3 mark? 1 mark is for drawing the circular. 1 mark is for showing the spacing. As the near the wire, it is close, and away from the wires have large spacing. And the 1 mark is for the direction. On figure 10.1 shows a wire that is carrying the current into the page. The circles on the figure shows a pattern of the magnetic field around the wire. On a figure, draw an arrow on each circle to show the direction of a magnetic field. You can annotate on the screen and shows the direction of a magnetic field. You can use the screen annotation. There's an icon of pen. You can use that to annotate on the screen and shows the direction of a magnetic field. The current is into. So use a right hand grip rule. Your thumb will point into and your fingers will turn around it. So what will be the magnetic field pattern? Right. At least draw 2 arrows for each circle whenever you are completing like an exam. At least draw 2 arrows minimum for each circle. The next is why the spacing of the circle increases as the distance increases. So it shows that the strength of a magnetic field is decreasing. So as the strength of a magnetic field decreases, the spacing between the lines will increase. Again, we use the right hand grip rule. Figure 9.2 represent a current which is into. So if the current is into the pattern, again, because a wire, if a circular wire, if a wire is straight, then it will produce a circular. Use a compass in exam to draw this, and a current is into. So your thumb will point into and your fingers will turn around. And State the effect of reversing a current has on the magnetic field produced. If we just reverse the direction of a current, what will happen to the magnetic field? The direction of a magnetic field will also be reversed. If a current is into, yeah, so the instead in a circular magnetic field, you cannot use the term poles. That does not make a real sense. So in this case, when it's a straight wire which produces a circular magnetic field, you just say that it will be opposite to the original direction or it will be reversed. As the direction of a current affects the direction in which the magnetic field produced. The magnet is removed and the horizontal current carrying wire is left on its own as shown in figure. On figure 9.2, sketch a pattern. So again, a wire is carrying current, so we have to sketch a pattern. So around this wire, it will be like a 3D image. This is, and current is into, like going towards Q, so this will be a magnetic field. So better in this pattern so you understand the 3D. The current is increased. State the effect have on the magnetic field. So magnetic field will be stronger. It will produce a stronger magnetic field. If we increase the current, it will produce stronger magnetic field. If we decrease the current, it will produce weaker magnetic field. The strength of a magnetic field depends on amount of the current which is passing. Figure 10.1 and 2 shows the vertical card is there. If we look from the above, this is how it looks like a current is coming towards us. On a figure 10.2, draw a complete magnetic field lines of force through P and indicate its arrow. So we have to show, because like when you're looking from the top, this is how it looks like. So the current is coming towards you. When a current is towards you, your thumb will point towards you and fingers will move around. So what will the pattern of a magnetic field? It will be like this. But we just only need a complete magnetic field line of a force, or only one circle we need. And we have to show how the magnetic field will point at. Then draw an arrow through Q to indicate the direction of a compass. The compass needle, because like if there is another magnetic field line here, so the compass needle, how it will point, we don't need the complete line. We just need a compass needle direction. So it will be in this manner, because like a magnetic field is circular around. So the compass needle shows a direction of a magnetic field and it is continuously changed in a circular magnetic field. State the effect on the direction in which the compass Q point. If we increase the current, so there will be no change or no effect, because if we change the direction of a reverse, the direction of a current, so it will point in opposite to the original direction. Like if it was pointing first towards left, now it will point towards right hand side. Figure 10.3 shows a view from above another vertical wire which is carrying the current up. A centimeter grid is marked on the card. A point W is 1 centimeter vertically above. At the point W is 1 centimeter vertically above the top of the surface of the card. State the magnetic field strength at S, T, and W in terms of R. So when we compare at S, because S is closer to the wire, so what we will use, weaker, stronger, or same strength? Because when it is closer to the wire, it will experience a stronger magnetic field. So this will be stronger. But what about comparing R with T? R has the same distance as T. It is irrespective of which direction, but because it has the same distance, so the strength will be same. And when we compare R with W, R and W also have the same distance, so they will also have the same strength. So irrespective of the dimension, if the distance is same, then it will experience the same force. In the question, a battery is connected between T1 and T2. There's a current vertically down. So the current is going down. If you look the card, so the current is going down. What is the on a figure, draw the magnetic field lines and indicate with an arrow in the direction. So how the magnetic field lines we draw? Because the current is down means like going into. This will be the magnetic field direction. Using a variable resistor, the voltage or the potential is gradually reduced. What happened to the strength of a magnetic field? This will decrease. And what happened to direction of a magnetic field? There will be no change. So direction of a magnetic field depends on direction of the current, and the strength of a magnetic field depends on the distance from the wire as well as the amount of the current or the voltage which is supplied. Is it clear till this point about the current, how the current produces a magnetic field and what are the patterns? Anyone having a doubt or a question? Okay.
No, sir. Clear.
Okay.